Okay, this is chapter 9, topic 9, the halogens. We have about 8 questions required. Very easy, shouldn't be more than 20 minutes. What is the color of chlorine gas? Is it lighter or denser than air? This is memorized. Chlorine is yellow green. I'm not gonna write it, I'll show you the answer. Okay, chlorine is green yellow, yellow green. If you say yellow green, you'll get the mark. How I memorize it? How I memorize it is chlorine, yellow, green. They both end with green. You know what I mean? Chlorine, yellow, green. Okay, so that's how I memorize it. Is lighter or denser than air? It's denser. Chlorine goes down. Okay, when it's in air, it sinks. How do you test for chlorine gas? Always remember chlorine is like Clorox. For those of you who have ever used cleaning products, Clorox bleaches everything. Okay, so when you put it on your clothes, it bleaches. So think of it like this. How do you know if there's chlorine? It's gonna bleach. And what we use always? We use litmus paper. So it bleaches litmus paper. Okay, so you could say bleaches litmus paper, or you can say how they say it in the course revision. It decolorizes a moist litmus paper. Decolorizes or bleaches litmus paper. They're both correct. Question 3 now. Write the anode and cathode half reactions that take place in the electrolysis of molten sodium chloride. Okay, we have anode and we have cathode. How I like to do it, I always start with the cathode. For electrolysis, the metal always goes to the cathode. The cation always goes to the cathode. That's how I have it memorized. Okay, at the cathode, remember, there is always a red cat. Reduction at the cathode. Okay, reduction, as you all know, remember oil rig. Oxidation is loss of electrons. Reduction is gain of electrons. Okay, so reduction is gain of electrons. So we know the cation always goes to the cathode, so sodium goes to the cathode. Okay, for electrolysis. Okay, for electrolysis, not for the galvanic cell. This is for electrolysis. Okay, so sodium is going to go to the cathode. So Na. We know reduction is gain of electrons. Okay, so Na, we're going to gain an electron, and we're going to end with Na. Type Na, it's a metal, so if you're going to gain an electron, it should be positive to start. And it ends like this. But Na at the start we're talking about molten. So molten means liquid. For those who don't know what something molten is like very, very hot liquid. Okay, so liquid, and it ends as a liquid. Okay, at the anode, cathode had the reduction, so anode will have the oxidation. And oxidation is loss of electrons. So chlorine, right? Chlorine. It's gonna lose electrons. So that means we're gonna have chlorine here, and since we're losing electrons, the electrons will be at the end. Okay. Chlorine, how does it exist? Chlorine exists as 2. It's diatomic, Cl2, right? Okay, and Cl is Cl minus, right? طيب, you have 2 chlorines here. So that means if you want to balance it, you need to put the 2 here. Okay, طب you have now 2 Cl, Cl2, okay. طب is it enough to have 1 electron? No, we have 2 minuses, so it should be 2 E's. Okay, very easy. This is the anode. But don't forget, it's liquid. It became a gas. It doesn't say liquid because chlorine is a gas. Let's check this. Like this. Okay. Okay, chlorine gas is produced industrially by electrolysis in a diaphragm cell. Answer the following question. What material is used as the electrolyte? Always, for an electrolyte, it's any aqueous solution containing what you want. Okay, any aqueous solution containing chlorine, the easiest one that is soluble is NaCl. Okay, this is the easiest one. Just memorize it if it comes. Okay, NaCl is the best electrolyte. Okay, and they said something about brine. I'm not sure what brine is. Let's see, actually. Yeah, brine is just salt water. So in other words, NaCl. Okay, let's close this and continue. What type of energy source is used in electrolysis? Obviously, the energy source in electrolysis, it's a battery, right? It's a battery. So how did they say it? They said, I think, a cell, dry cells. Yeah, you could say dry cells. Or electricity. Electricity makes more sense. Electric battery, electricity. Electricity is here. These questions, you memorize them, yani. State the materials from which the anode and cathode are usually made. The materials are usually inert, but here they want it to specifically be titanium for the anode and steel for the cathode. These, by the way, aren't in the chapter 7 notes. So I'm not sure if this stuff will come, but for some reason she wrote it here. she wants you to do them. So you should do them. Write the anode and cathode half reactions that take place during the electrolysis process. Some people are going to make the same mistake. They're going to make the mistake of just copying what we had in part A. For the chlorine, it's going to be correct. Why is it going to be correct? It's because it's the same thing, chlorine. But so what's going to be different at the cathode? Why at the cathode? Remember, we're talking about here electrolysis of NaCl, right? Like we said as the electrolyte. At the cathode, you have the Na. It's being electrolyzed, and it was originally, when we were using in part A for molten sodium chloride, it was Na plus E minus to produce Na. Why is this wrong? Because now we're talking about electrolysis of an aqueous solution. And remember, at the cathode, if it's not copper or silver, then what's going to be produced? Hydrogen gas. Always. Now, you need to memorize the reaction for hydrogen gas being produced. If you want an easy way to memorize it, it's always you're starting with water. Okay, any solution contains OH minus and H plus. You're starting with water inside the solution because, again, it's NaCl solution, right? So there's some water in it. So remember, reduction, as at the cathode, you always have reduction because red, cat, reduction, and it's the gain of electrons. So always, you have water, you're gaining electrons. Memorize, it's 2, 2, 2. Okay, memorize, you have water, you're gaining electrons, right? And remember, you have OH minus and you have hydrogen gas. Okay, because it's either H or OH in water, right? Okay, you need to balance this now. You have 2 here, but you have 3 here. What do? You multiply this by 2, so now there's 4, and you multiply this by 2. Okay, now this is balanced. But since you have 2 here of OH minus, you need to put a 2 for the electrons. And this way, you have it balanced. Very easy. Question, let's see. Besides chlorine and hydrogen gases, what important byproduct is produced? Obviously, it's going to be sodium hydroxide. People are going to say, how is it sodium hydroxide? Okay, look, you have NaCl, right? Aqueous. And as well as that, you need to know, we took this in a previous chapter. In every solution, you always have H plus and OH minus, right? طيب. When you did electrolysis, you ended up getting chlorine gas, right? So we finished from this. And you ended up getting hydrogen gas. So we finished from this. So what is the byproduct left over? NaOH. Okay, always. You look at what wasn't produced in the electrolysis. Very easy. Continue now, question 6. Okay, write the net ionic equation for the reaction that takes place when a few drops of silver nitrate solution are added separately to the aqueous solution's flow state observations you expect to make. Okay, silver nitrate is AgNO3. Remember, we're talking about halogens and silver nitrate. You guys know that silver nitrate reacts with Cl, Br, and I. Cl giving a white solution. Actually, you know what? I'll just show you the notes. It's written over here. For chlorine, it's a white precipitate. Bromine, it's creamy precipitate. And iodine, it's yellow. Remember, ILY. Iodine loves yellow. Bromide is creamy. Br, Cr. Okay, and chlorine is just white. So you can memorize that. Okay. And these are all the net ionic equations. They're very easy. You don't have to memorize them. I can just give it to you how I do it. Okay, so sodium bromide. You have bromide. Okay, so what we're going to get? We're going to do Ag plus, always Ag plus what do you have? Bromide. Br, what's the charge of Br? Minus, right? Because the halogens are all minus. To produce AgBr. Aqueous, and it's a precipitate, so it has to be solid. What is the observation? Creamy precipitate. Potassium iodide, right? Again, they're all going to be the same thing. Ag plus I minus, aqueous, to produce AgI, which is solid. What's the color going to be? Yellow precipitate. Sodium chloride, Ag plus Cl minus, aqueous, to produce AgCl, solid, white precipitate. Potassium fluoride. Did we say anything about fluorine? No, right? So no change, right? Let's see. Question 6. No change. You produce AgF, which is just soluble. Okay. Question 7. Complete and balance the following ionic equations where no reaction is expected, write NR. Remember, for halogens, we have displacement reactions. Let's open here. Displacement reactions, you have halogen plus halide to produce the halogen minus plus the halide. Okay, basically, the one with 2 as the subscript should be more reactive than the one with a charge. Okay, the halogen should be more reactive than the halide. Halogen is the one with 2 as a subscript, and the one halide is the one with minus as the charge. So let's see here. For a reaction to occur, the halogens in the periodic table are like this, okay? The ones that are most reactive start at the top, the ones that are least reactive are at the bottom. Type, let's see, Cl2 plus Br minus. The halogen, the one with 2 as the subscript, should be more reactive than the one with the minus. Let's see, Cl2, is it more reactive than Br? Yes, because it's above. So that means there will be a reaction. So all you have to do is just swap them. It's going to become Cl minus plus Br2. And the states, you change them. Okay, Br2 gas, Cl aqueous. But they said balance. This should be 2. The one with the minus should always be 2. Okay? I2 plus Br minus. Let's see. The one with 2 as a subscript should be more reactive than the one with minus. Is I above Br? No. Okay, so there's going to be no reaction. F minus Br2. People here, they're going to be like, oh, there's going to be a reaction. Because they only look at the first one and the second one. They don't, they think, oh, the first one should be more reactive than the second. No. And if you switch the order, it's still the same thing. Okay, so this F minus. Remember, we look at the one with 2 as a subscript and see if the one with 2 as a subscript is more reactive than F. So here I'm not going to see if F is more reactive than Br. Why? Because what's the rule? The one with 2 as a subscript, the halogen, should be more reactive than the halide, the one with just minus. Okay, so let's see, is Br more reactive than F? No, it isn't. So again, no reaction. I minus Cl2. Again, you don't look at the I first, you look at the Cl2 because it has 2 as a subscript. Let's see, Cl2, is it more reactive than I? Is it above I? Yes. So let's complete it. All you have to do is just swap them. Okay? All you have to do. And then just swap the states and balance. Always the minus should have 2. Let's check this. Over here, 7. Put a 2. Okay, they want us to keep these as aqueous. Okay, yeah, makes sense. You can keep these as aqueous. The Br2 keep it as aqueous, and the I2 keep it as aqueous. Okay, so to clear something up before going to the last part, for displacement reactions, they're always, the last 2 should be aqueous. Okay, always. The second thing is here they forgot to put color in CCl4. Okay, CCl4, so that's what the question is. Yeah, CCl4. They forgot to put this in, like they forgot to write the heading. Okay, so people will just see brown and perfectly be like, oh, what's that? Okay, brown also can be written as orange brown. Okay, that's completely fine. Right, let's do the second part. I just gave you the answers. What are the colors of bromine and iodine and cyclohexane, which is something similar to CCl4? Okay, like we said, orange brown for bromine. So bromine, they just put orange, but you can put orange brown. And iodine is purple. Very easy. Question 8. Use the trend to predict the spontaneity of the following reactions. Okay, let's see. Cl2 plus 2Ki. The 2 should be more reactive than the one without the 2. They didn't put the charge here, but they put it with a K. Okay, we don't care. We only care. The one with the 2 should be more reactive with the one without the 2 as a subscript. Remember, I'll give you, this is given in the exam in the periodic table. Let's see. So Cl should be more reactive than I. Is Cl more reactive than I? Yes. So we're going to put a tick. Spontaneous. I2, 2Kf. Remember, the one with the 2 should be more reactive than the one without the 2 as a subscript. So I should be more reactive than F. Is it? No. Br2, 2KCl. The one with the 2 should be more reactive than the one without the 2. BrCl. Is Br more reactive than Cl? No. So only A should be spontaneous. Yes. Write the following. Write equations for the reaction of hydrochloric acid with the following: NaOH, CaOH, MgS, CCO3, CO. Okay, for question 9, I'm going to go through it a bit quick, but I'm just going to write on the side how the reaction goes. Okay, hydrochloric acid. Acid has reactions with what? Okay, I'm going to put the same thing. First, acid plus metal gets you salt plus hydrogen gas. This is from salt preparation. Acid plus metal oxide gets you salt plus water. Let me put H2O. Acid plus metal hydroxide gets you also salt plus water. Also, acid plus metal carbonate gets you salt plus carbon dioxide gas plus, I think it was water. Wait, let me check. Yeah, plus water as well. Yeah, that's it. Okay, so if you apply these to here, you're gonna get the correct answer. Let me show you the correct ones. Okay, acid, it's all HCl plus something, HCl plus something, right? So first they start with NaOH. What's NaOH? Metal hydroxide. So acid plus NaOH to get you the salt. How do you find the salt? HCl, NaOH. I always explain this. To find the salt, you box up the middle. For the people who don't watch my channel, okay, you always box up the middle. Okay, so HCl plus NaOH, the salt will be NaCl. Okay, and water. I'm using this rule. Okay, these are the 4 rules for people who don't watch my channel. Okay, I always give them to the people who watch. Okay, the next one was, I think it was calcium hydroxide. Yes, okay, again, same thing, metal hydroxide. Acid plus metal hydroxide gets you salt plus water. HCl, CaOH. How do you know what the salt is? Box up the middle. It's gonna be CaCl, but the formula is CaCl2. Why? Why is it CaCl2? Okay, here's the thing. You have Ca2 plus and Cl minus. If you crisscross, right? If you crisscross, the 2 goes down here, and this one goes here. So it's CaCl2. Okay, so CaCl2 plus water, and again balance it. I'm sure everybody knows how to balance. Very easy. طيب, the next one was the metal magnesium. Acid plus metal gets you salt plus hydrogen gas. HCl plus magnesium, right? How do you know? How do you know what the salt is? Box up the middle. You're gonna get MgCl2. Why? Because Mg is 2 plus, Cl is minus. Crisscross, you're gonna get MgCl2. Okay, so you get MgCl2 plus hydrogen gas. Easy. The next one was calcium carbonate, which is metal carbonate. You have HCl plus calcium carbonate. You get salt plus carbon dioxide gas plus water. How do you know what the salt is? Box up the middle. CaCl2. How do you know? Because it's Ca2 plus and Cl minus. Crisscross, you get CaCl2. So CaCl2 should be the first thing there. I don't know why the rest at the end. Plus carbon dioxide gas plus water. Very easy. The last one was copper oxide, which is a metal oxide. So you can use this rule. Okay, so we used all 4 rules. Acid plus metal oxide gets you salt plus water. How do you know what the salt is? You box up the middle. So you have HCl and CuO. Box up the middle. Again, CuCl2. Why CuCl2? Because Cu is 2 plus, Cl is minus. Crisscross, you're gonna get CuCl2. Okay. Plus obviously the H2O. Very easy. Question 10. A few drops of silver nitrate were added to a hydrochloric acid solution. So AgNO3 was added to HCl. What do you expect to observe? If you're adding silver nitrate, AgNO3, to HCl, right? Cl. What are you going to observe? White precipitate, right? Because the Ag with the Cl, right? Write a complete and the net ionic equation for the expected reaction. Okay, the net ionic will be very easy. Ag plus Cl minus to produce AgCl solid. Obviously, these should be aqueous. They also said write a complete equation. So you're going to put AgNO3, which was aqueous, or actually AgNO3 plus HCl or I think AgNO3 should be liquid. I think it should be liquid. It should be liquid. Right? Should be liquid. HCl is the solution, right? To produce, we said AgCl, solid, and what's left over? HNO3, right? We're done from the Ag, we're done from the Cl. What are you left with? HNO3, right? HNO3, it should be aqueous as well. Let's check this. Maybe the state symbols I messed up. To complete, they put them all aqueous. Okay, that's fine, I guess. You can change this here to aqueous. Okay, very easy. Vapors of concentrated ammonia and hydrochloric acid are mixed together. So ammonia and hydrochloric acid are mixed together. What do you expect to observe? Write an equation for the expected reaction. So this was never explained to you, but you need to memorize that when you mix ammonia with HCl, you can get thick white fumes. Okay, observed. Okay, memorize it if it comes. Okay, write an equation for the reaction. Again, I don't expect this stuff to come, but you need to memorize it in case it does. Okay, just add NH3 and HCl for the reaction. Very, very easy. NH3 plus HCl. You're adding one hydrogen, so it becomes NH4, and you're left with Cl. Very easy. Okay. It's an acid base, by the way. It makes sense to get a solid because NH3 is a base and HCl is an acid, right? Base, acid. You know, when you mix an acid and a base, you get a salt. Okay, so NH4Cl is the salt being produced, which apparently is thick and white. Okay. The next one, write one possible equation for the reaction that can take place when propane is chlorinated. Again, it wasn't explained to you in class, but apparently chlorination is when you add chlorine gas and it steals a hydrogen, it donates a chlorine and in turn takes a hydrogen. So that's what chlorination is. So enter you have over here C3H8. Okay, these questions, by the way, questions 9, 10, 11, I doubt they're gonna come, but you should know that. Chlorinate, because they're in the material, plus Cl2. What does the chlorine do? It has a tendency to attract the H. So when it attracts a H, what's it gonna become? HCl. But HCl never exists as HCl2, right? So what does it do? It says, oh, okay, I have an extra chlorine, I'm gonna donate one to you. Okay, so it's gonna donate now to the C3H8. When it donates the chlorine, remember it took one hydrogen away. So now instead of having H8, it's going to be H7. So that's what the process of chlorination is. Okay. Question 12. Which sequence best describes the relative reactivity of halogens from most reactive to least reactive? Very, very, you know, F, Cl, Br, and I. This is very important. I'm 100% sure this will come in your exam. Okay. F, Cl, Br, and I. F, more reactive than Cl, more reactive than Br, more reactive than I. It goes from up to down. Reactivity decreases as you go down. Okay, so chlorine, bromine, iodine. Yes, that's correct. This is higher than this, higher than this. Chlorine, iodine, bromine. No, bromine is higher than iodine. So this is wrong. This is correct. Bromine, chlorine, iodine. No, chlorine should be before bromine. Bromine, iodine, chlorine. No, chlorine should be the first one. Iodine, bromine, chlorine. Chlorine again should be the first one. So the only correct one is A. Okay. We're done here. Thank you so much for watching and good luck in your exam.